So, well, let's see. Now that I have considered this, what's this M? Well, this M is the matrix that is obtained by removing the first row and the second column. But that is exactly this entry that I have here. Well, what is that? Well, that is A to 1, the entry on the second row and first column. Well, but that is exactly the traditional determinant of a 2 by 2 matrix. This is A times D minus B times C. Now, just one word on this. Because if we look at this definition, it's rather artificial. Why is that we have to fix this one? Can we take an expansion on not the first row? Can we take an expansion on the second? Can we take an expansion not on the j's, but on the other coordinates? I don't know. For the moment, we'll take the definition as it is, but later we'll see that this is just one way to compute this number, and more than that, the number that we have here comes naturally when we consider linearity questions. In what sense? Well, linearity in terms of the columns. But well, that's for a later discussion. Now, I want to show just one more computation that will convince you of the following thing. Let me take the determinant of a 3 by 3 matrix. A, B, C, D, E, F, G, H, I. Probably that's not a good quantity because we use I for the rows, so I'm going to replace it with a K just for the sake of the problem. So what is this? Well, according to the definition that we have here, this better be the sum from j equal to 1 up to 3, the number of columns that we have, to the negative 1, j plus 1, a 1 and j, determinant of the minor associated with 1j. Now, what is the thing that we have in our case? Well, this is negative 1 to the power of 2, a11, determinant of m11. We'll see the correspondence right here. Plus negative 1 to the power of 3, a12, determinant of m12. Plus negative 1 to the power of 4, a13, determinant of m13. Now, let me fully expand this expression that we have here. This is a11, determinant of the minor. Well, what is the minor associated here? In this case, it is obtained by removing the first row and the first column. So that corresponds to the matrix EFHK minus A12, determinant of the matrix that is obtained by removing the first row and the second column. So what we have to consider is only this. So that is DFGK. And finally, plus A13, determinant of the matrix that is obtained by deleting the first row and the third column. So the matrix that we consider is the one that is obtained from here, which is DEGH. Now, in this case, we're fortunate because we already have the definition of the determinant